Hey IB students, we are studying topic 4, statistics and probability, and this is going to be a video on just simple probability and conditional probability. We're going to look at 3 types of examples. We're going to look at a Venn diagram example, we're going to look at a tree diagram example, and also a two-way table. Alright, so let's start with the Venn diagram problem. So story goes, the probability a student likes to watch archery, event A, is 0.4. The probability that a student likes to watch basketball, event B, is 0.7. The probability that a student likes to watch archery and basketball is 0.3. So the first question is asking you to find the probability of A union B, or A or B happening. So IB will accept one of two things. You can use a formula for the probability of A or B, or if it's a Venn diagram problem, you can fill in the Venn diagram, and they will accept that for partial credit for your method point or for an accuracy point. So I'm going to show it with the Venn diagram first, and then I will also show it using the formula. So anytime I'm filling in a Venn diagram, if I am told the probability of A and B, I always fill that in first. And so what they're telling me here is that the probability of A and B, which is an intersection, is 0.3. And that 0.3 represents my overlap between archery and basketball. Now let's focus on the probability that a person likes archery, which is 0.4. That 0.4 needs to be this entire circle. I've already accounted for 0.3, which leaves 0.1 left over. So the entire circle totals up to 0.4. And then the probability that a student likes to watch basketball, event B, is 0.7, would be the entire circle of B. I've already accounted for 0.3, which leaves me with 0.4. So 0.3 plus 0.4 gives me the 0.7. The entire Venn diagram box needs to total up to 1, which is the probability of all possible outcomes. So right now I have 0.3 plus 0.4 plus 0.1, which is 0.8, which actually leaves me with 0.2 out here. Okay, so the question says find the probability of A or B. A or B is going to be anything in circle A or in circle B. So I actually want to grab all 3 of these numbers. So that would be 0.1 plus 0.3 plus 0.4. That's not a plus sign right there, so that's a 0.4. So that would give us 0.8 total. And if you were going to try to use the formula to find this, the formula is located in your formula packet in topic 4. And so when you go to your formula packet in topic 4, at the top of topic 4, you've got all of your statistics information, but right there in 4.6 are our probability formulas. And so you'll see combined events. So the probability of A or B is the probability of A plus the probability of B minus the probability of their intersection. So if I were going to use that formula, the probability of A or B equals the probability of A plus the probability of B minus the probability of the intersection of the two. It's basically saying you're taking this whole probability of the A circle plus this whole probability of the B circle, but that would double count the middle, so you subtract the middle. That way it's not double counted. That's really what's happening in that formula. So my probability of A is my 0.4. So you're grabbing the entire probability that someone likes archery, or the entire circle, plus the probability that a person likes basketball is 0.7, minus the probability of their intersection, 0.3. So that would be 1.1 minus 0.3, which would be 0.8. So ultimately our probability of A or B is 0.8, whether you use your Venn diagram to draw that conclusion or whether you use your formula. Part 2 says label and find the area that represents the probability of not A and B. Not A is the complement of A. So not A would be everything outside of A, and it also needs to be B. So I find it helpful, if you've got a pencil, to check those off. When you're looking for an intersection, we don't grab everything, we want the overlap. So the probability of not A would be the section outside all of the circles and the section that's exclusively B. The probability that it is B would be the section that's exclusively B and also the overlap in here. And so when you're looking for an intersection, you're looking for the area that has two check marks, a check mark from the first condition and a check mark from the second condition. So the first thing they want me to do is label this. So this would be the probability of not A and B, and then find what that is, and that would be my 0.4. The next question says, I'm going to erase these check marks here. The next question says, find the probability of it not being A and also not being B. So not A would be everything outside of A. Not B would be everything outside of B. So that would be outside the circles and also exclusively A. And I'm looking for the overlap of those two. The only area that has two check marks would be the 0.2. All right, last part says, given that a person selected likes archery, find the probability that they like basketball. So you have two options. You can use your Venn diagram, or you can use your conditional probability formula because it's a given. I'm going to start with the Venn diagram. I think that's the simplest and the fastest way to get an answer here. So whenever you have a conditional probability, it reduces your sample space. So given that a person selected likes archery, I'm going to erase these check marks here. I am now narrowing down my sample space just to this circle. You can ignore all the stuff on the outside, just looking at this circle here, which is 0.4. And so I'm giving a probability, and it's now out of 0.4. Find the probability that they like basketball. Well, of that 0.4, it's the overlapping section of people that also like basketball. So that would be 0.3 over 0.4. Don't leave a decimal in a fraction, so multiply top and bottom by 10, and we have 3/4 or 0.75. The other way you can do this is you can use your conditional probability formula. And your conditional probability formula says, scoot that up a little bit, the probability of A given B, given that B has happened, is the probability of A and B divided by the probability of B. So when we are talking about the conditional probability, the second part, B, is your condition, and that is also the probability in your denominator. So I'm going to show this using that formula. Start by writing your formula down. The probability of A given B is the probability of A and B given the probability of B. So in this case, the probability of A given B is archery, a probability that a person likes to watch archery given that they like to watch basketball. Okay, so in my denominator, I have the probability that someone likes basketball. So the probability that they like basketball is 0.7. Oh, I'm so sorry. Let's scratch that. This is the formula that you are given in your problem, in your formula packet, but this is not in the format for the question that they've asked. It's just confusing because there's an A and a B and there's an A and a B in here. You actually have to apply this to the question that they're asking, my bad. Given that a person selected likes archery, so the given statement is that they like archery. I'm going to actually write archery here so I don't mix it up with the A and the B that's in the formula. Find the probability that they like basketball. There we go. So find the probability a person likes basketball given that they like archery, which means in your formula, in your numerator, you're going to have the probability that someone likes basketball and likes archery. And in your denominator, you're going to have the probability that they like archery. So the probability that they like archery is going to be our 0.4 that we're given in the original problem, or the entire circle. In the numerator, it's the probability that they like both basketball and archery. That's our overlap. That's our 0.3. And you can see we're getting the exact same answer that we got before. We're getting 3/4 for our answer. So one way is just reducing your sample space and kind of using logic. The second way is using your formula. Just don't get confused with the A and the B. Make sure you rewrite the formula with your particular story set up in the correct positions. All right, last part to this question. If events C and D are mutually exclusive, find the probability of C and D happening. Well, mutually exclusive means they have no overlap. So the probability of C and D happening would be 0. A visual representation, obviously C and D does not apply to that Venn diagram, but if they are mutually exclusive, C and D do not have any overlap in their circles. Okay. I think I'm going to stop our video here, and I'm going to split this video out into 3 separates. So this was our first video on Venn diagram. Next up is going to be tree diagrams. Thank you so much for listening.